guys, today's lesson is on arcs and chords. Okay, an arc is basically a piece of a circle. Okay, so we're going to talk about arcs today, and a chord is going to be, of course, we've seen that word already, that's a segment inside the circle. Okay, one of the things we need to remember in this particular section is that all circles have 360 degrees. That's one of the key pieces of information we're going to need to help us through this lesson. Okay, first of all, let's talk about a central angle. A central angle is basically an angle with its vertex on the center of the circle. So right there, that angle, angle ABC, has its vertex right at the center of the circle. So the central angle is angle ABC. Okay? And if you look at this, one of the things I mentioned here is that the measure of a central angle, this measurement right in here, if that measurement is 80 degrees, then what we say is the measure of the arc, that arc from A to C, that piece of the circle there, is also 80 degrees. So the measure of a central angle is equal to the measure of an arc. So that takes us to the definition of an arc. An arc is basically, like I said, a piece of a circle. It's an unbroken part of the circle, connected from A to C. It's not broken, it's a continuous piece. And in this particular picture here, we see arc A to C. That is one little type of arc there. Now, there's actually two specifications for types of arcs. There's a minor arc and a major arc. This, A to C, happens to be a minor arc. Let's talk about the definition of a minor arc. A minor arc is an arc measuring less than half the circle. So it's basically less than 180. We said that circles have 360 degrees. So if I cut a circle in half, that's 180 degrees on each side. So less than 180 would be less than half the circle. All right, so again, in this particular case, we said A to C is considered a minor arc. Minor arcs are named with two letters. Okay, they're always going to be named with two letters. Major arcs, on the other hand, is an arc measuring more than half the circle. So if it's more than half the circle, it has to be more than 180 degrees. Major arcs are always named with three letters. So if you look at this picture, I have arc A going towards D and ending up at C. That is more than half the circle, but we need three letters. I can't just call that AC, because then the question would be, which AC am I talking about, right? Am I talking about this AC, or am I talking from A all the way to C here, right? So you have to use three letters so you know which part you're talking about. So the bigger one is going to get three letters. So we're going to call that arc A, D, C. And one of the key things we need to remember there is there could be a whole bunch of points. Like there could be another point right here called E. Now, what do I call it now? Do I call it AEC or do I call it ADC? Well, here's the thing. It doesn't matter, okay? You just have to pick any one point anywhere in between here, starting at A, pick a letter in between, and end up at C to be your major arc. All right, then there's also the semicircle. And, of course, the semicircle is exactly half the circle. So we have two halves to our circle, right? We cut it in half. And you guys might remember that that half line is our diameter there. That splits the circle into two. So here I have half a circle, and here I have half a circle. Now, the question is, which half are you talking about? If this is from E to G, are we talking about the top half of EG or the bottom half of EG? So when we talk about semicircles, again, they're exactly half, but you need to name them with three letters there. You've got to have three letters so you know which half you're talking about. So the top half in this picture would be arc EFG. You would need another letter down here to name the bottom half. Let's call that D. So the bottom half could be EDG, but you have to have three letters to actually name the semicircles as well. Okay, let's go into a little bit of identification here, help us to identify our different parts of our circles here. Okay, let's take a look. All right, so we're going to identify the major arcs and the minor arcs in the semicircles in this picture. So again, minor arcs are anything less than half the circle. Well, here is a diameter. Right there, O is the center. Okay, so that means I want things that are less than 180. So A to B, right, that would be less than 180. A to C would also be less than 180, right? So arc AB, arc AC. Okay, what else? How about B to D, right? That's another one that's less than 180. You could also do C to D, also less than 180. And again, it could be CD or DC. It doesn't matter. Now, what else do we have? We could also do from A to D. A to D is also less than half the circle, A to D. So that's another one that we could use. another minor arc as well, A to D. Let's pick out some major arcs. Major arcs are going to be the bigger ones. They're the ones that are going to pass the 180 mark. So for example, if I start at A and I pass C and I go all the way to D, that's definitely more than half the circle if I start from here and go all the way around to here. Okay? So arc A, C, D, right there, that would be considered a major arc. Let's see, we have another one. We could do A to B to C going this way, right? We could do from A, passing B, all the way to C. Right, so A, B, C. Now, if you'll notice in that one, I chose to pick the B, but I could have also picked D. So those two here, A, B, C, and A, D, C, they are the same arc. They are the exact same arc there. Okay, so those are some examples of some major arcs. Now, the semicircles, of course, are half the circle. So the top half or the bottom half in this case. So again, we need 3 letters from those. So C, A, B would be 1 across the top, and we have on the bottom C, D, B. And again, you could name those either way. That could be B, D, C. It doesn't matter. Okay, adjacent arcs are basically arcs that have exactly 1 point in common, and they don't overlap. So these two arcs would be adjacent. They're next to each other. They have that point A right there in common. So from C to A and A to B. That would be a pair of adjacent arcs. There are other pairs in this picture as well. You could also do A to B. That would be like another pair. And B to D. All right, that's another pair of adjacent arcs. So they have to have a letter in common. Okay, they must have a letter in common to be considered adjacent. You could also have like a major arc and a minor arc be adjacent as well. So for example, ACD, arc ACD, that whole thing there, and arc DB. They both have D in common. They're both next to each other. So that's a minor and a major that are adjacent as well. Okay, let's look at this next part. You have to remember this. The measure of the minor arc is equal to the measure of the central angle. And I talked about that earlier over here. I said whatever the central angle is, the arc is going to be the same thing. Okay, that's what we're talking about here. So we need to remember that in order to be able to answer this next set of questions. So right here you can see that you have a 60-degree angle right there. So we know if that angle is 60, that arc there is also 60 degrees. Now, I can continue right here and go all the way over, and that makes a little semicircle. We know semicircles are worth 180. So if I take 180 minus 60, I get 120. So once again, we have an angle here, another central angle of 120 degrees. So the arc is also going to be 120 degrees as well. And then on the bottom, we have a semicircle down at the bottom here. And that semicircle is 180 degrees. All right, let's see if we can answer these questions. First one says the measure of arc AB. That is a minor arc. It is 2 letters. So that one is, of course, 60. The next one is C to A to B. Well, that happens to be half a circle, right? That's 3 letters. Semicircles can be half 3 letters, and also major arcs are 3 letters. So that could be either with 3 letters. So that one happens to be a semicircle. That's 180. The next one's going to be a minor arc, arc AC. Okay, arc A to C is 120. Arc C to D to B. Again, that's another half a circle there. That's another one that's 180 degrees. All right. Next one we have is angle. That's a measure of an angle. AOC. That's the little angle right in there. That's 120. Right? The measure of the angle is the same as the arc. They're going to be the same. Angle BOC was next. BOC, well, that's a straight line. If you remember, all of our straight lines are always 180. Okay, and it's also based off of the arc. So that straight line is based off of that arc right there of 180, or the top arc, it doesn't matter. The next one is arc A to C to B. So we have to go start at A, go all the way around to C, and all the way around to B. So basically, we've got to add some arcs together. This is going to take us into our arc addition postulate. We're going to add the 120 plus the 180 to get that. So 120 plus 180 is going to give us 300. So that big arc that starts here and goes all the way around to here is a 300-degree arc. And that, again, that makes sense because this little piece that's left is 60, right? If I start here and go all the way around to 300 and then another 60, that would be my 360 for the circle. All right, and the last answer here is A to B to C. So this time we need to start at A, go to B, and then all the way end up at C there. So we're going to take the 60 plus the 180 there, and we get 240 degrees. So that arc that starts at A and ends up all the way over here at C would be 240, which again makes sense because the rest of the circle is 120, and 240 plus 120 would be 360 total. Okay? All right, that takes us into our arc addition postulate. So let's take a look at that. All right, arc addition is just like our angle addition, segment addition, right? Little plus little equals big. So in this case, we're looking at, it says the measure of an arc formed by two adjacent angles is the sum of the measure of the two arcs. So when you have two angles that are next to each other like that, you can add them together, right? So the big arc is going to be equal to the little arc plus the little arc would equal the big arc. All right, so let's take a look at these examples that we have here. All right, so you can see right here you have a 65-degree angle, which means if that angle is 65, the arc is also 65 there. All right, so that arc there would be 65 degrees. And likewise on this one, we have an angle that is 63, so the arc is also 63 as well. All right, so now this is 180 degrees. This whole thing right here is a semicircle from here all the way to here. So all of that has to add to 180. So you have to add the 65 and the 63 together, right? You get 128, and 180 minus 128 would be 52. So this arc would be 52, and this angle would also be 52. All right, let's answer the questions. And of course, the bottom half we know is 180 because that's a semicircle. All right, the measure of arc H to J. Well, that arc right there is 63 degrees. The measure of arc F to G to H, that's these two together. So we have to add the 65 and the 52 together, and we end up with 117. So that whole arc there from F all the way to H, because, and again, that says FGH. That is actually incorrect. You don't really need three letters there because that's less than 180. So that really should be the measure of arc FH there. That's really what that should be because that is a minor arc. All right, let's look at the next problem over here. All right, we have an angle that is 40. Now, one other thing I want to bring to your attention is that you have two intersecting chords here, okay? You get vertical angles just like we had before. So both of these angles are going to be 40 degrees there. You also have a right angle that is 90. Okay, we have a 90-degree angle. And we can figure out the missing piece, right? We know that if that angle there is 40, the arc is 40. Likewise with this one, that arc would be 40. We know if this is 90, that arc out there from C to D would also be 90. So we can identify a diameter here. Pick out any diameter. There's actually two. There's one here going through the center of the circle, and there's one here. It's not going to matter which one you pick. It's not going to matter because all of that would be 180. So I have to add the 90 and the 40 together. Okay? Add those up. We get 130, and of course 180 minus the 130 there would be 50. So that arc would be 50, that angle would be 50. Now, the question is how much is left? How much is the rest of this that is there? Right? How much is all of that arc? Well, that arc's going to be the same as this angle, and you have 180 degrees here. So 180 minus 40 leaves me with 140. So that angle is 140, and that arc is also 140. It is easier oftentimes to find all the measurements before you answer the questions. All right, the first question says CDE. CDE. Once again, that's not half the circle, okay? That should say the measure of arc CE is what that should say. Again, a typo there because that is not more than 180. If I take 90 plus 40 there, I get 130. That's how much that is. That arc from here all the way to here is going to be 130 total. And the next one is arc B to C to D. Again, that is not half the circle either. So that should actually say the measure of arc BD. That should just be two letters there. So we have to add the 50 and the 90 together, but that will not be more than 180. In fact, that works out to be 140 there. Okay, so be careful when you're naming. Clearly there were some mistakes in here in terms of the notes that we have. So we're going to get rid of those and call them by what they are. They are actually minor arcs because they are all less than 180. So look at the next example here. All right, so what do we have? We have an angle that's 30. All right, so that means this little tiny arc out here is also 30. We have an arc that is 105. So that means, an angle that's 105. That means the arc is also 105. You do have some intersecting segments there, some chords that are intersecting, so that's going to give you some vertical angles. So if that's 30, and then the arc is 30. And we have some diameters in here, so we have semicircles, so all of that is going to add to 180. I've already used up 30 degrees there, so 180 minus 30 leaves me with 150. So that means that that arc is 150 and that angle in there is 150. And I have one missing piece, which I can, again, easily find. I have from here all the way to here another diameter going across the middle there. So that's another 180. So I can add up my 105 and my 30, right? I get 135, and 180 minus 135 is going to be 45 there. So that means that that little angle is 45, and that arc there is also 45. Okay, let's answer the questions. We want the measure of arc LMN. LMN. Again, that's a small arc. That is not the case. We need 2 letters from that. That should say the measure of arc LN, just from L to N. That's going to be the 45 plus the 30 there. So we've got to add 45 plus 30 to come up with our math there of 75. So that arc there from here to here would be these two added together would be 75 there. And the next one we have is L to M to P. Now that one is pretty big. If you look at this, it starts at L, it goes towards M, and it ends at P. That is more than half the circle. So that one is correct, having 3 letters. We do need 3 letters for that. That's a major arc. So we're going to add the 45, we're going to add the 30, and we're going to add the 150. And actually, the 30 and the 150 is already 180. So you can take 180 plus 45 there to come up with your answer of 225. Okay, so that arc there is 225. All right. The last concept we see here is this concept of congruent arcs. And of course, it's kind of common sense that if you have, within the same circle, if you have 2 arcs that have the same measure, their angle measures are going to be the same. All right. So if you have 2 equal angles here, you're going to have 2 equal arcs here. So in this particular picture, you have arc ST is equal to arc UV. So not only there will those arcs be equal, but those angles will be equal as well. Okay, if there's any piece of this video that you would like to go back and rewatch, feel free. Okay, take care. Good luck.